Hello, in this video we will talk about exploratory factor analysis, or called EFA, and show how to do EFA with R. So, what is exploratory factor analysis? It is quite like principal component analysis, but what's the difference between them? The EFA is to find the latent factors, which will be assumed to cause or generate these observed variables. So these factors are not the linear combination of variables. It is like an opposite way. So these observed variables are coming from these factors, and E1 to E5 are those parts of variance for these variables that are not explained by these factors. So this is called EFA. So the goal of EFA is to explain the correlations among a set of observed variables by uncovering a smaller set of more fundamental unobserved variables underlying the data. So these hypothetical unobserved variables are called factors. So the model can be represented as, so this is the observed variables, xi equals a1 times f1 plus a2 times f2 and so on. Then in the end plus the ui. So here xi is i's observed variable, and fj are the common factors. So this is the latent factors. And p less than k and ui is the portion of variable xi that is unique to that variable and not explained by the common factors. So ai is the degree to which each factor contributes to the composition of an observed variable. So ai is the parameter. So the steps of exploratory factor analysis is quite like principal component analysis. So first we have to decide how many common factors to extract. Then we extract common factors. Then a process called rotating factors. Then we will compute the factor scores. So next we will show example of exploratory factor analysis using R programming. So to illustrate the process, you will apply EFA to the correlations among 6 psychological tests. 112 individuals were given 6 tests, including a non-verbal measure of general intelligence, general, and a picture completion test, picture, a block design test, blocks, a maze test, maze, a reading comprehension test, reading, and a vocabulary test, VLCAB. So the question is, can you explain the participants' scores on these tests with a smaller number of underlying or latent psychological constructs? Then we go to RStudio. First, we load the library psych. Then we set option 2 and we get the data frame called covariance, which comes from ability.cov data. So we show this covariance. Data frame. So 6 variables, their covariance. Then we transform this covariance to correlations. So this is the correlations between 6 variables. We set random seeds. So to determine the number of factors to extract, we will use function FA parallel. Then Input is the correlations and observations 112. FA both means we will show both the lines for principal component analysis and exploratory factor analysis. And we also set 100 iterations for simulation. Then add horizontal line 0 and 1. We will show how it is going. So this is the result. So this line is for the principal components, and this line for the exploratory factor analysis, and this red one is for the principal component analysis simulation line, and this is for exploratory factor analysis simulation line. So what this means? This is for factors which has corresponding eigenvalues for correlation matrix. So if you watch our previous video for principal component analysis, you will see this criterion. We'll choose maybe one component. But for the factor analysis, we will choose 2 because these 2 eigenvalues is larger than 0. In the principal component analysis, the eigenvalue should be larger than 1. And factor analysis, its eigenvalues should be larger than 0. So these 2 fulfill these requirements. And eigenvalues should also be above this simulation line. So these 2 criteria will tell us that we will choose 2 exploratory factors here. Then next step is to extract the factors after we have decided how many factors in this model. So we can use FA function again. FA correlations n factors 2 and rotate equals none, because here we do not do any rotation. The Fn is the method of extract these factors. So here I use PA, principal axis. Let me show how it is going. So this is the result for the extracting factors. So similar as principal component analysis, here listed 2 factors, and these are parameters for this variable, which is linear combinations of these 2 factors. Then H2 is the variance, about 57% the variance of this variable are extracted by these 2 factors, and 43% of the variance for this variable is not explained by these 2 factors. So similarly for these 6 variables, and this table shows about cumulative variance 60% in total for 6 variables for observed data explained by these 2 factors. Then next we will rotate the factors to make them more easily explainable. So we use the same function, but we set a rotation is varimax. Varimax because this is for the orthogonal rotation. So which means the factors are not correlated. We show the results. So this is the loading again is different from the function running without rotation, right? But you can see here it's easier to explain what these factors are. So the factor 1 has high parameters with these 2 variables. And these three variables with high parameter with factor 2. So we may construct the factor 1 is for verbal ability, and factor 2 for general picture blocks for the unverbal ability, right? Then last step is to extract the loading parameters for the score. So we can use the results, then find the variables called weight. So this is the weight. So which means general can be modeled as the linear combinations of these two factors with this parameter coefficients, and picture with these two coefficients for these two factors, and so on. Thanks for watching.